For number 4, the function f of xy, that's the number that the farmer can produce. 120 square root 4x squared plus y squared. The x represents the unit of labors and y gonna be the unit of capital. We're gonna compute, see the key term, marginal productivity. That means the marginal of the product function of labor and capital when x8 and y12. So let's identify the piece here. Marginal means the derivative. And the part here, since the product depends on x and y, x as the labor and y as the capital. The marginal product of labor, so I'm going to write here, the marginal labor is x, right? And the product is the f, marginal is the derivative. So this one means you find the partial derivative with respect to x. And the other one, the marginal product of capital. Capital is a y. So that means you look for the partial derivative of the function with respect to y. When that means you're going to evaluate when x, y as the order pair 8, 12. That's how to interpret the problem. Okay, the function is provided. So you're gonna, first time you're gonna find the partial derivative with respect to x and then with respect to y. The second round, the second step, you're gonna replace x by 8 and y by 12 of each partial derivative. You guys okay with the way to interpret the question? How to go for it?
I think so.
Okay, that's good. All right, so first one, we're gonna find the partial with respect to x. Partial with respect to x is the partial with respect to x of 120. I'm gonna write the square root as power 1/2 because we're gonna refer to the power rule or the general power rule. And the 120, that is the constant multiple or the coefficient, right? Or the constant multiple. And this one is in the power form. And our goal is working on the partial derivative with respect to x. So gonna take 120 out of the way and then work on the partial derivative of the quantity for x squared plus y squared to the power 1/2. Refer to the general power rule. The power r is 1/2. And this is the expression that you're gonna treat it as a function g of x, y. That we're gonna find the derivative eventually. The general power rule, 120 as a coefficient, right? And then the power 1/2 multiplied by the quantity for x squared plus y squared to the power 1/2 minus 1. And then multiplied by the partial derivative of the x, partial derivative with respect to x of 4x squared plus y squared. So this part, I will put it as general power rule. Okay, the new power becomes negative 1/2, and I'm gonna clean up. It becomes, and also 120 and 2 reduced to be 60. I take up this number first, so it can be 60 times the quantity for x squared plus y squared to the power negative 1/2. And then multiply by the derivative of this portion with respect to x. Again, this is x, this is x. The y term gonna be 0. I mean, the derivative of the y, the derivative of y squared with respect to x is gonna be 0. So that part, the derivative will be 4 times 2x and then plus 0. I'm gonna make a note here. This part is gonna be this part. And the derivative of the y square is gonna be 0. okay? And then just clean up a little bit. So it becomes, this is 8x, 8 and 60, that becomes 480 times x times 4x squared plus y squared to the power negative 1/2. I'm gonna make some room here to make sure we have enough for the later part of the problem. And recall the power negative is the reciprocal of the power positive. So I'm gonna write it in the form that easy to manage for x squared plus y squared to the power 1/2. And the power 1/2 is the square root for x squared plus y squared. This is the partial derivative with respect to x, or the marginal productivity of labor. We call x is the labor, right? And then the f is the productivity. And the marginal means the derivative. So this is the first one. And we're gonna find the value of this as x equals 8 and y equals 12. What you're gonna do, you just replace the x with the value 8. And then the y with the value 12. And then in the square root, and then get the number out. So let's put in the calculator real quick. Let's see what number do we have. So 480 multiplied by 8 divided by, if you have the calculator, just go ahead and work on the number. And the bottom is square root of 4 times 8 squared plus 12 squared. And I get 192. Oh, you got different number? Let me double check.
Yeah, at the end, 192, yes.
Okay, so good. So this is the marginal. So I'm gonna write it as the marginal productivities of labor. That is the rate of change of the product if the change of the labor changed by 1 unit. Okay, and the same way as the marginal productivities of capital for the partial derivative with respect to y, or the partial derivative with respect to y of the term 120 times the quantity 4x squared plus y squared to the power 1/2. So we treat it as the constant multiple 120 times the partial derivative with respect to y of 4x squared plus y squared to the power 1/2. And keep going. So 120 times 1/2 times the quantity 4x squared plus y squared to the power negative 1/2. So let me write the power here in different levels so it will not get messed up with the outside power. And then multiply by the partial derivative with respect to y of the quantity 4x squared plus y squared, which is the inner function. This time target on the y, okay, on the y. So then this portion will be treated as the constant term. Clean up the numbers, 120 and 2 reduced to be 60. This portion, the derivative will be 0 plus 2y or just 2y. So the partial of the product with respect to y or with respect to the capital equals 60 times quantity for x squared plus y squared to the power negative 1/2 and then multiply by 2y. And we write it as 120 because from 60 and 2, and then the y as the numerator, and the power negative will bring it down to the bottom with the positive power, and the positive power 1/2 is the same as the radical, and we're going to evaluate when x equals 8 and y is 12. Do the same way as when we computed the previous term, 120. This time the y is 12. Y is on the top as part of the numerator. And the bottom is square root of 4 times 8 to the second plus 12 to the power second. And then in the calculator, it should be, let me see, 120 times 12 divided by the radical 4x squared plus 12 squared, and I get 72. You guys check the number for me. So this is the marginal productivity.
I got 72 too.
That's good, of capital. So we got two numbers, this for the one with labor and this one for the one with respect to the capital.